What we're going to talk about today is, yesterday we talked about lines. They go on forever and ever. Okay? What we're going to talk about today are pieces of those lines. We're going to talk about the measures of them. We're going to talk about betweenness. All things that common sense wise you probably know about. You just didn't put geometry terms to it, if that makes sense. What do you guys think about the way I labeled AB? Would that have been the way you've done it if I asked you to and you didn't know how to label a segment? Think about it. We did yesterday. What makes a line go on forever and ever? What aspect of it? The arrows. So when I'm talking about line AB, I put what in the end of the line or the segment up above the AB? I put right here, I put arrows, didn't I? Okay? Everyone agree? Well, if I'm just talking about the A to B, just that piece of it, I'm not going to put the what? Agreed? Do you see how BA is the same segment as AB, right? We're talking about a segment there. Line segments are a specific piece of a line, has a starting point, has an end point. You could say this line starts at A, this line segment starts at A, ends at B. You could say this line segment here starts at B, ends at A. Same thing, correct? So now the beautiful thing is we can start getting into measures. Huh? That'd be fun, huh? We get to have some numbers in math. We didn't hardly have any numbers yesterday, did we? Now, there are other segments here. Now, is this the same line as this? Is line AC the same line as line AB?
Yes.
Yes, it's the line that goes on forever, ever, that goes through AC and goes through AB. They're the same thing. However, is segment AC the same as segment AB? Correct. A to B, segment AB is just from here to here, is it not? Would everyone agree? Segment A to C is from here to here. Segment B to C is that piece, isn't it? So, as you can see, segments are different than lines, of course. Okay? And I wrote every way you can write the three segments up there. Now, so as I said, we're going to talk about distance. And as I erased it, but I'm going to write it up here again. Let's say that when I write 5 up here, what do you think I'm saying? The distance from A to B is what? If I wrote a 3 right here, what am I saying? The distance from B to C is what? What would this distance be then? Did you need any kind of special theorem to tell you that? You didn't, did you? Because this is just like if this was Tulsa, this is Jenks, and this is Owasso. And this is a straight shot to either of them. I know this, of course, isn't right. But if I said, okay, I drove to Tulsa, then from Tulsa I drove to Jenks, how far did you drive? 8 miles, right? The two smaller parts equal what? The whole thing. Anytime you have anything built up into parts, aren't these two smaller parts here going to always equal the whole thing? Is that a hard concept? That's pretty easy, isn't it? Does that make sense? So I know if this whole thing was 10 and this one was 2, what's this one going to be? That's easy peasy, isn't it? What we've just talked about, and everybody look at on the book and find the definition of betweenness. This is one of your first examples of how simple concepts can sound complicated. What we just talked about was the definition of betweenness. Betweenness of points. Look down there, the key concept. I mean, let's be honest. Let's read this. Point M is between points P and Q if and only if P and Q and M are collinear and PM plus MQ is equal to PQ. You know what that's saying? That if these three are on the same line, one of them is in between the two others, then the two smaller parts added together have to equal what? See how the language can... The language is there for a reason. I'm not saying geometry is wrong for having this because they made it complicated. Because it's worded like this, it covers every situation. This is always true, period. This is a theorem or a definition. Okay? It's always true. It needs to be written like that in the rules of math. But in concept, it's just that a simple concept you already knew, isn't it? Does that make sense? Talking about two things being between each other on the same line. The two smaller parts equal what? The whole thing. Part of your key to getting better at math and especially geometry is being able to see the simple concept from the what? Math definition. That can be tough sometimes. Does that make sense? All of you, if you look at this one up here, all of you will understand that AN plus what? NB would equal what? The whole thing, right? Does everyone agree? Now, what we've got to get into is how we can write this stuff. I need to have a way to be able to talk about the distance from A to B. This is not the distance from A to B. This is, I'm saying, you know, it's like saying, my name, Mr. Stump. I'm Mr. Stump. You don't say, look, there's 5'11" man. Because that's how tall I am. Or there's 5'11". You see what I'm saying? You said, hey, there's Coach Stump. Coach Stump's measure and height is 5'11". You see the difference why you don't do one or the other? So we've got to be able, now we're just talking about the segment. Now we want to have a way to say how big it is. Well, guess what? That's why it's so important you put this segment sign or a line sign or something above it. Because guess what AB by itself means? What does it say up here? Somebody? The distance from A to B. That's what that means. When you see two capital letters beside each other, written out like that in this geometry class, from this point on, I'm referring to what? The distance from A to B. Whereas here I'm talking about a second segment. What am I talking about here when I say the distance from A to B? What is that? That's a number, is it not? Would you agree? And what is the number in this case? That's what AB is. What's AC? That's the distance from A to C. What is AC in this picture up here? It's 8. That's a number, which is 8. BC, that represents a what? Number, which is what? What is the distance from B to C? 3. Once again, because I hadn't said that, that's why another reason why the definition between this sounded so weird. What are they talking about? Here after a while you can say AB plus BC equals AC, but for right now I would suggest saying to yourself the distance from A to B plus the distance from B to C equals the distance from A to C. To remind yourself that that's what that represents. So everybody, let's get that finished writing down, and then we're going to get to something else. We're going to talk about a very important thing that you'll deal with for a long time. Let me know when everybody's got that written down. Everybody got that? Okay. What we're going to talk about are two words. First word is one you use an awful lot. And that is the word equal. Then after that, we're going to talk about a word you've probably never used. Congruent.
Congruent means the same, doesn't it?
They're not the same thing. That's for sure. These two.
No, I'm talking about congruent and same.
Not
Congruent
quite.
means like.
Equal, it actually does it. And that's what we're trying. Equal, Mason, when you say equal, what do you think?
The same.
Exact same thing, right?
Yeah.
So what, exact same thing. What sign do we use? That's the equal sign, isn't it? Okay. Well, I'm going to draw two pictures over here. Make that A, make that B. Let's say that this is from there, there's 6. And I'll freeze this and let you guys write it down, okay? So right now, just listen. C, D. So distance from there to there is 6. Now, why is this statement incorrect?
Because they're not equal.
You're not viewing the same way.
And not congruent.
You guys are just trying to think. You're doing good.
They are congruent. They're not equal.
Well, I mean, answer, does this make more sense? Why?
Not the same.
Segment AB, and then is the exact same thing as segment CB. Does that sound right? Are they the exact same thing? Is this
Yeah.
the exact same thing as this?
Mm.
No, one's up here, kind of slanted like that. This is AB, right?
Yes, so they're not congruent.
I mean, am I the exact same thing as someone who's also 5'11"? Is he Coach Stump? No. Are we the same height? Yes, our heights are equal, but we're not the exact same thing, are we? So we need something to be able to say that things are kind of the same thing, but so it's incorrect to say that these are the same thing. Now, why is this correct? Why is that correct?
Because the distance from A to B is the same as the distance from C to D.
Distance from A to B is what? 6, right? The distance from C to D is what? Are they the exact same thing?
Yes.
Is 6 the exact same thing as 6? Okay. So that's why we need something besides equal to say that, we need to be able to say that these are the same size, right? Well, guess what? They make congruent. And what congruent means, even though we don't need this part of it, congruent means two things are the same shape and size. no shape because they have no thickness, right? Lines. But when we get into figures, things like that, we'll get more into that shape and what that represents. But these are obviously the same size, so that's why we use congruent. Now, we need a symbol for that. This is my Corning thing for the day. Everybody listen. You guys know what that is? What sign that is?
Congruent.
Approximately, right? Means almost the same thing, right? And that means equal, right? Well, equal married approximately, and they had a baby, and it was called congruent.
Wow.
Yeah, that's what
That is cute.
that's the point. Sorry. The point I'm making is, congruent things are almost the same thing, but not quite, right? So that's why this is a good sign for it. That is the sign for congruent. So what would be a correct statement? That segment AB is what? Congruent to segment what? That is correct. This is what? Wrong. Okay? That sound, you can say that's semantics if you want, but it is, like I said, a lot of what we're doing here is we're learning the language. Now, does two things being congruent lead you to that their distance is the same? Do two segments being congruent lead you to this? Yes. Because AB is congruent to CD, I didn't have to tell you how long they were. If I said this was true, then what could you say? That their distances have to be what? Equal. Because congruent means the same what? Size and shape. Okay? But you will use congruency all the time, John. Again and again and again. So it is important that you understand the concept of it. When you've got all that written down, I'd like you to get out practice workbook. You haven't gotten it yet. Just watch it for right now. I'll give you mine. Or just watch and then write it down now. Okay, that's all you do.
What's your question? What was your question?
Okay.
Just copy it from where he's gonna write it down, okay. That's what he's been telling
Remember, all of this is going to be uploaded online. So, for some reason you don't have your workbook, which you're supposed to. For now, you can watch, pay attention, and then write it from that, from the video. Now, let's everybody look at number 1.
What page?
1-2. We're on section 1-2.
The first one?
The second 1-2. On page 4. Okay, if I was to measure this, let's look at this. What would the distance be? That we're talking about inches here. So it would be 1 and what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, but it's not base 10, so I have to use a fraction here, don't I?
I've got the same
page 4.
Oh, you said the first one, Dale.
Says the
It
second
says
one.
the second one now.
Anyway, doesn't matter. 11 out of how many total marks are there? 12, 13, 14, 15, 16 total marks. Now, what do I need to put on the end of this? Inches, correct? Everybody got that? Now, centimeters are easy. They're a little easier because they're base what? Base 10, so I can use decimals. This length would be 4 point, how many marks are there? 2 and what? Centimeters. You guys okay with that? We got to be able to do that. On this one right here, find the measurement of each segment. Assume that the figure is not drawn to scale. That's one thing you always need to assume, is that it's not drawn to scale. Just because things look like they're equal doesn't necessarily mean they are. They need to be marked that way. Now, right here, what's the distance from P to S going to be? Whatever 18.4 plus what? Which would be?
23.7, or, I mean, 1.
23.1 centimeters. This one over here, what are you going to have to do? Number 5.
Subtract.
The whole thing's 100. XY uses 89.6 out of it, so whatever's left out of 100, which would be what? 10.4 centimeters. You're all right. If you're not making a mistake, you're not trying. Anybody makes fun of anybody for making a mistake in here, you're not going to be things aren't going to work out very well for you. Easy, isn't it? And then we get to these. These we do need to talk about. Okay? Come on, buddy. Okay. Guys, even though the word algebra is written up there, when you see 6x, 3x, things like this, inside 2x, x plus 2, 5x minus, what does it say?
10.
Minus 10. I'll write the rest of it on there. Okay? When you see that, kind of stuff, you think of algebra, don't you? What was the biggest thing you probably learned how to do in algebra? There may be different things, but equations. Solve an equation, wasn't it? I think of algebra, I think of variables, x's and y's, and equations, right? Anytime you see a geometry problem that has components in it that look like an algebra problem, 99% of the time, the problem wants you to use the information given to create a valid equation. Now, in this section, we're talking about betweenness, line segments, things like that. I bet you they're going to use something like that to want us to create an equation with this information. So your best thing to do is when they don't have a picture drawn, if you can't visualize it, when they write stuff like this, what could you do? Draw the situation, right? It doesn't have to be perfect. The situation here is find the value of x at KL if K is between what? Okay, that's meaning it's a point in between the two others. So, I've got a dot here, I've got a segment, right? And then I've got another dot, what, right there? Which one's the one in the middle? Which one did they say was between? Huh?
Okay.
Okay, so I need to make that K. Does it matter what I make the other two? It does. In this case, it's what? So So I can make, which one do you wanna make this one? What about this one? Okay, now you've got a picture to label. And a lot of times, the situation you're seeing here will be much easier to deal with if you see it as a picture. So let's label that picture. Remember, when I don't have anything above it, I'm saying the distance from J to K is what?
6x.
Remember, X represents a number, right? So I'm saying it represents 6 times a number I don't know. So I can label J to K as what?
6x.
Agree? What about K to L?
3x.
Now, if it helps you do stuff like this, I know when I'm doing them up here, I do that, just to kind of help my mind see that the distance from here to here is 6x, distance from here is 3x, right? Everybody okay with that? Now, is it weird because there's variables in there? Yes. But it's still the same concept. That's a number, and that's a what? Number. It represents a number. Now, what's the whole thing? What have we learned about this in this section? You probably, if you go back and look at what you'll see are theorems or things we've talked about, they'll probably tell you what to do. What did we learn? That the what? We talked about that what? The two smaller parts added together equal what? You think that might be your equation or your relationship they're wanting you to write an equation for? Because would you guys have any problems with this? And don't write this down. If I said this was 5, this was 10, then that would make this what? The equation is what? 5 plus 10 equals what? Everyone agree with that? Okay. It's the same concept, it's just I don't know what they are. JK plus what? KL equals the whole thing, which is JL, right? Well, I have some things to represent that, don't I? It's what? What is J to K? 6x. Plus. What is K to L? 3x. What is J to K?
27.
So that's equal to J to L. Yes, sorry. That's 27, isn't it? Have I created a valid equation with the information given? Does that make sense, that relationship? The two smaller parts added together equal the whole thing? Yes.
We always have 6x and then 3x.
No, it'll change. Look.
Would it matter if they switch to KL for 6?
Yeah. Well,
And 3 for JFK?
Well, no.
Then you have to make it your own.
well, you have your situation. Whatever you put in for JK, it needs to be 6x.
Well, I'm saying if it's not there, if they don't give you
Well, they'll always give you something to take with it. So now we've created an equation. Sit up. Is this a hard equation to solve? Solve the equation. The reason they have the equation is because they wanted you to solve it. If it looks kind of odd, there's probably some simplifying to do. Is there some simplifying to do there? What do I get? Divide both sides by what? X is equal to? In this problem, what they asked me to find? What X is equal to and what KL is equal to. I found X. I found that it was what? What is K to L?
9.
Why, how'd you get that?
3 times 3 is 9.
KL is 3 times whatever number X is. What is X? So X is 3, so that makes KL what? Okay? Stop, don't write this down yet. Let me do this one over here first, then I'll give the assignment, and then you can write it down. Okay, this is the last thing we're going to do. One other little thing to talk about. But is this situation any different? What is the difference between number 7 and number 6? I can use the same picture, can I not? Well, what's the difference? They gave me different values for each, didn't they? But is the concept the same? Do the two smaller parts added together equal the whole thing? What is J to K in this case? What is K to L in this case? What is J to L in this case?
5.
this down when we're done. Watch. Stop writing. See what I mean? That's easy, isn't it? So what's my equation? The two smaller parts added together. This part, which is what? Plus this other smaller part, which is what? Equals the whole thing, which is? Now, is that a weird or kind of complicated looking equation? Maybe. If it looks weird, there's probably some, and what you're going to find, because you're plugging things in geometry, you get a lot of equations that need to be simplified before you can start moving things around. What needs to be simplified here? What's a simpler way to write this? Simpler way to write 2x plus x is to write it as
3x.
plus 2 is equal to 5x minus 10. Now, what do you do here? You just pick somewhere and start, don't you? Getting rid of things. What would I do? Okay, so you want me, what do you want me to do? Subtract, add 10? Add 10 to both sides. That gets rid of that over there, just leaving what? These are like terms. What does this become? And this still stays what? Now what's your next step?
Subtract.
I want to get my variables on one side, everything else on the other, so I'm going to subtract 3x, where I just have a 12 on the left side. But whatever I do on this side, I have to what?
Do on this side.
I'm left with what?
2x.
What's my next step?
Divide the 2 on both sides. And x equals 6.
So I found x equal to 6. And what is KL then equal to? Well, KL is whatever x is, which in this case is what? Plus 2. What's KL? Okay. Now, before you start writing this down, one other thing I want to show you. Okay. I have a segment. Does it look like I put that right there in the middle? I tried to. Does that look like it's right dab in the middle? Okay. It may look like it, but you can't assume that those two, it is right exactly in the middle, unless you see something like this. That is a mark that you'll see from now on out. That's a way of visually representing it on a picture, saying that this distance is the same as what? But if you don't see that mark, you know, one could be 5.9 and the other one 5.95, right? But this is a mark meaning two things are what? Congruent. That's a way of, another kind of shortcut on a picture to be able to say, okay, those two things are the same. So if you see that, you can't assume that they are congruent. Okay? The assignment is numbers 1 through 32. Very important that you write problems, draw figures, show all steps of work. They don't have to be works of art. Now, if you think on a problem like this, I'm going to give you any credit if you just write that. No, you're wasting my time and yours. You're cheated. You've copied it from somebody. I'd rather you not do it than do that. I'd rather you try to get it completely wrong than just skip it because it had an equation. You can learn from mistakes. Yes.
So homework's out of the book.
Yes.
Okay.
The practice we use for notes, and like I said, you know, there's still a lot of problems that we didn't do that we could do a review for a test on. I could assign that instead of booklet. That way we have practice workbooks. That, in fact, and you may like that better.